God morgen alle sammen. Velkommen til dette webinaret med RF Elements i regi av Avantis. Mitt navn er Asle Kristoffersen, og takk for at dere tar dere tid en travel hverdag til å delta på webinaret. Det setter vi pris på. Tidsmessig så regner vi med å bruke rundt 30-40 minutter. Kom gjerne med spørsmål. Men jeg foreslår at vi tar en spørsmålsrunde og oppsummering på slutten av webinaret, så klarer vi å holde litt flyt i presentasjonen. Presentasjonen fra RF Elements er på engelsk, men det er bare å stille spørsmål på norsk, så skal vi gjøre vårt beste for å eventuelt oversette. Så har du et spørsmål, skriv det inn i spørsmålsfeltet i webinarapplikasjonen. Så samler vi de opp. RF Elements er jo en innovativ produsent av kvalitetsantenner til 2,4 og 5 GHz frekvensområde. De har jo både frittstående antenneprodukter og integrasjonsløsninger som er spesialtilpasset radioprodukter fra for eksempel Ubiquiti, Mikrotik og Cambium Networks. Og ikke minst har de nå også kommet noen ganske smarte løsninger som vi skal se litt nærmere på i dag, nemlig twistport-adaptere og symmetriske sektorantenner. Med oss fra RF Elements er vi så heldige å ha med oss Mikael Mardiak, som er Product Manager hos RF Elements. Good morning and welcome, Mikael.
Good morning, thanks very much. Thank you everybody that you come to the webinar. So today's webinar will be about the symmetrical sector antennas. First of all, I would like to mention just a few things about our company. So, very short, we are based in Slovakia, which is in the European Union. We have here a headquarters as well as an engineering site, and we also have one representative office in US, in Austin, Texas. Our main focus is the innovation. So our products look different, they work different because they are different, because we are trying to be innovative. We are manufacturing a different kind of wireless network equipment, but today I would like to speak about the symmetrical sector antennas. So what does it mean, symmetrical sector antennas from RF Elements? The best way how to imagine it or to show it is to compare it with the traditional sector antennas. So the beam from the traditional sector antennas are usually wide in one direction. So here it's horizontal, but narrow in a vertical. So it forms a flat beam. On the other side, the beam from the symmetrical sector antenna, it forms a 3D shape. You can imagine it when you have a flashlight and you turn it on. So the beam of the light that is coming out of the flashlight is very similar to the beam from the symmetrical sector. And such a beam, it's very unique, and we call it symmetrical because the beam is symmetrical in any direction. So it's symmetrical in elevation cut as well as azimuth cut. Such a beam, it has also advantage or benefit in a real-life deployment. And one of it is that it can reduce the null zone. The null zone is the zone close to the tower. So usually when you use traditional sector antenna, customers that are close to the tower, they have either very bad signal or they don't have any signal. But since the symmetrical sector antennas, the beam is symmetrical also in a vertical direction, you can, by using these antennas, you can cover also areas that are close to the tower. So even the customers who are close to the tower can have a good signal. The shape of the beam is one thing, but another benefit of the symmetrical sector antenna is that the beam is frequency constant. So as you can see, the shape of the beam, it doesn't change with the changing frequency. It slightly changes, but the shape is still the same. And this brings one benefit also in real-life deployment. So imagine when you decide to deploy a symmetrical sector antenna. So you will choose the channel with less interference. So the best channel to achieve a higher throughput. But as the times go by and a new ISP will come to the same site, that channel might be not the best available. So you decide to change the channel. And here, with a symmetrical sector antenna, there is no need to go again on the tower and trying to find the position again, because the beam of the symmetrical sector antenna, it's very similar even if you change the frequency. And this is an example how the beam is changing with the frequency in comparison to the traditional sector antenna. And here you can see that traditional sector antenna, the beam is changing a lot when you change the frequency. The beam of the symmetrical sector antennas is very unique, but also it has more interesting features. And one of these is the gain. So the gain is frequency balance in a whole spectrum. So in a 5 gig, you can see this one is for symmetrical sector 30-degree antenna, and here you can see that it's still more or less around 18 dBi. And for those who might, maybe you are asking if those two graphs, so the gain for a horizontal and vertical polarization is similar, so I can guarantee it's completely similar. So the gain for both polarizations, so for horizontal as well as vertical, is completely the same. This is very, very good if you are using, or if you are using in your deployment a MIMO. So for MIMO, the same gain for horizontal and vertical polarization is very, very important. Symmetrical sector antenna has one big benefit, and one of it is side lobes. So here you can see the very popular antenna. So it's a Ubiquiti AirMax antenna, 19 dBi, 120 degree radiation angle. And for those who don't know what are the side lobes, so you can see the blue things on the back side of the antenna as well as on the side. So this is a back and the side lobes radiation, side radiation, and this is what causes a lot of RF pollution, and this is unwanted radiation. And as you can see, a symmetrical sector antenna, they do not have any side lobe, so the signal is radiated into the main lobe, so the direction where you want to have a signal. This is because of the type of the antenna. The symmetrical sector antenna, the type of the antenna is called a scalar horn. The beam is highly focused to achieve better performance from RF point of view. And the fact that the symmetrical sector antenna, it doesn't have a side lobe, it also works on the other way. So you will, with the symmetrical sector antenna will collect much less interferences, because if there are source of interferences on the sides, antenna will not collect interferences from that source. It's isolated from the side radiation, so it will just collect interferences from the main lobe. That's why it's very good for environment with a lot of interferences. And side lobes and unwanted radiation is not just something that you can see in a cheaper antenna, but it's also a problem of more expensive antenna. And for example, this is another antenna from Ubiquiti network. It's an AC sector, 45-degree radiation angle. And here you can see that there is slightly less of the side radiation, but still, even if this antenna comes with the shielding, there is a lot of side radiation, so something that you don't want to have on your side. We have different kind of models of a symmetrical sector antennas. We have 7 different models. The narrower one is 30-degree, and then it comes up to 90-degree with a 10-degree step. And the reason why we have so many models is very simple. It offers you a unique opportunity or perfect opportunity to scale your network as you really need it. So, for example, if you have a 120-degree sector and you have a lot of customer there, so probably you will face a really bad throughput and performance of the sector. So by using a symmetrical sector antenna, you can split this 120-degree sector into 4 30-degree sectors, which means that same amount of the customer will be served by 4 APs, so your performance will go up as well as throughput. But this is one way. It also, the scalability is also when you have customers concentrated on one place. For example, a village. So it doesn't make sense to cover whole 120-degree sector and cover also the areas where you don't have customers. It makes much more sense to cover only the sector or the area where you have a customer. So with the symmetrical sector antennas, you can, for example, pick a 50-degree symmetrical sector antenna, so you will just cover your customers. We have a lot of questions about the symmetrical sector antenna and the distances. So what is the distance? This is just to illustrate. I have to mention here, this is the theoretical maximum. So this is basically a math. This is a theoretical maximum of the distances with the symmetrical sector antennas. So in real life, it depends on many factors like RF environment, the level of interferences. Also, it depends on the landscape. So this is just to give you a clue. But from real life, we know what the customers were able to achieve. So for example, we have a customer in the US and they were able to achieve 14 kilometers by using a 30-degree symmetrical sector antenna, and on the other end, so on the CP, they were using a power beam CP. We also have few other customers, and these ones are from Latin America or Central America. So Mexico, guys in Mexico, they were able to achieve 15.5 miles with a 30-degree symmetrical sector antenna. But on the other end, they have a rocket dish, so a dish with a 31 dBi gain. Another customer in Guatemala with a 60-degree symmetrical sector antenna, they were able to achieve 14 miles. The coverage of symmetrical sector antenna is different comparing to the traditional sector antenna, and here you can see how different is the coverage. So symmetrical sector antenna, it's, if we say that is a 30-degree So it means that it's really a 30-degree radiation angle. So when you have customers which are not in the main lobe, so outside the main lobe, they will have really low signal or no signal at all. The symmetrical sector antennas, they offer you excellent scalability, as I mentioned, but it also brings you benefit in other scenarios. And one of the scenarios is when you are trying to deploy your network or providing connectivity in a hill country. So when you put your antenna on the tower and you would like to cover also mountains but as well as the valley, I'm sure that if any one of you already tried this one with a traditional sector antenna, it was very hard to do it, or it was impossible to do. But with symmetrical sector antenna, it's very easy because vertical performance is the same as a horizontal. So you can cover a valley and hill even without using a down tilt, so a mechanical down tilt. If you need to use a mechanical down tilt, so you don't need to have a coverage on the, for example, here on the opposite mountain, you can do the down tilt on 22 degree, which is really enough for such an antenna. This is to summarize where is good to use symmetrical sector antenna and where to use traditional or our sector carrier class antennas. And I would like to mention here, we are not saying that symmetrical sector antennas are the only solution or that those antennas can solve any problem. Symmetrical sector antennas are different and they have benefits that can, with this benefit you can solve problems that you were not able to solve with a traditional sector antenna. So to summarize it, it's very good when you have a narrow sector, so customers are concentrated on one place and you would like to cover just those customers, or you have a very dense sector, many customers spread it or distribute it over the whole sector, so you need to split the sector into the smaller sectors. Regarding the distance and hills and close customers, I already mentioned it. Also the antennas are small, so you can place it on a tower when you are facing a space limitation or a wind load issue, because comparing to the traditional sector antenna, they are small, so you will not have that problem with the wind load issue. So we have 7 different models of symmetrical sector antenna. Here you can see a few technical details. We have much more technical details. They are all in our datasheet on our web page. So if you are interested in, you can go there and download it and check it in more detail. One thing here I would like to mention, you can see that the gain, the highest gain is for 30-degree symmetrical sector, so the symmetrical sector with a narrower, with the narrowest beam. And maybe you are wondering that 18.5 dBi gain is not that much, but don't forget symmetrical sector antenna, they don't have side lobe, so all the energy is radiated to the main lobe. So this gain, don't be confused. We have customers that they replaced antennas with 20 dBi gain and they have much better performance, so better signal level, higher capacity, better quality of the signal. So this is something that you have to consider if you are thinking about gain. We started with 39, 60, and 90 models of symmetrical sector, but now we have all models available. It means that now you can really scale your network or pick the model that you really need it. So if you need 50, you can pick a 50 and cover just the zone and the customer that you really want to cover. I already mentioned the size of the antenna, and symmetrical sector antenna is very compact. Comparing to the traditional sector antennas, it's the size is like 1/4 of its size, so very compact. And not just the size is very important, but also the construction. But symmetrical sector antennas are made from very solid metal structure. We are using just best available material, so there is a die cast, stand, or extruded aluminum. Also, the plastic parts are UV resistant. The hardware is stainless steel. The brackets are made from aluminum. So we don't use any surface treated materials because we know that customers are using our antennas in different kind of weather conditions. We have customers that they are using it in the United States, I mean in very hot climate, in very hot and humid climate. We also have customers which are using our antennas in very cold climate, for example in Alaska. And so far we didn't have any complaints about the construction, so the antennas can survive very extreme conditions. And also the weight of the antenna, the biggest one, so the 30-degree symmetrical sector antenna, it only weighs around 2 kilograms. The symmetrical sector antennas are something new and different kind of sector antenna, and I'm sure that many of you already noticed that it comes with a very interesting or unique or not common connector. So symmetrical sector antenna comes with the twist port connector, and I would like to tell you or explain you more about the twist port connector, so what benefit it brings and why we end with the twist port connector. So with the twist port connector, the installation and or removing the radio or adapter from the antenna is very easy and quick. So you just twist and lock, and the radio is installed on the antenna. And the reason why this is able to do is that the twist port is our quick locking button pending waveguide port. So there are no cables or RF connectors. We call this twist port also a virtually no loss. We call it virtually because there is a very small loss. We are living in real life, so physics still works. There is loss, but if you compare it to the setup with the cables, the loss is almost unmeasurable. And speaking about the cables, how we end up with the twist port connector. So usually this is the normal outdoor wireless paradigm. So when you want to create a link or to install the antenna or AP at one point, you need 3 units. You need a radio, antenna, and the pigtail. So something that will connect the radio to the antenna, and when you are installing it, you will put the radio on the antenna and connect it with the pigtails. But we are trying, or we are a very innovative company, and we are trying to push the limits far. So we decided that we will remove the pigtails. So we remove the pigtails at the first step because we don't like cables, and also pigtails are source of loss. So since we remove the pigtails and all the connectors on the antenna side and the radio side, we were trying to find a way how to connect the antenna with the radio. So what we did, we moved a waveguide feeder from the antenna side to the radio side. And by doing this, we add a waveguide on the radio side and also on the antenna side, and creating a twist port connector. So basically what we did, we moved all the electronic parts from the antenna side to the radio or the adapter side. And this also brings a benefit in a real-life deployment. Since we move all the electronic parts from the antenna to the radio, there isn't any part or electronic part on the antenna side that can be damaged or that can fail. So it's very easy to debug when something wrong happened. All you need is to climb on the antenna and remove the radio or remove the twist port adapter from the antenna, because you know that nothing can be damaged or can fail on the antenna side. With the traditional sector antenna, when something like this happens, you need to climb on the tower and put down the radio as well as antenna, find the source of failure or what is the problem, and then again climb up and mount whole antenna and trying to find the proper position, so put it in a correct direction. So this also, the twist port antenna with the twist port adapter, it also saves a lot of time when something bad happens. So to summarize, we reduce the number of units by 1, so from 3 to 2, and also the number of components. And this means that we reduce the point of failure, so something that can fail. As I mean, the twist port adapter, as I mentioned, is our proprietary patent-pending connector. So what can you connect to our antennas? Even if the twist port is our proprietary connector, it allows you to connect different kind of radios or different kind of platforms to any twist port enabled antenna. And you can do it by using a twist port adapters. So twist port adapters are used to connect a third-party radios, so not the radios without twist port connector, to the twist port antenna. And how such a adapter works, it's very simple. So if you have an radio, you just push inside the adapter radio until you hear click, and this is installed. And when you want to remove the radio, you just push the button, press the button and remove the radio. It's very simple. So what kind of radio can you connect to the twist port antenna? Twist port connectors are compatible with radios from a Ubiquity network. So here are all the models just mentioned here. Some of the connectors come with the shielded and unshielded version. So shielded version comes for a Rocket 5 AC Lite and also for a Rocket M5. The difference between shielded and unshielded version is simple. The shielded one comes with the integrated shielding inside the adapter. So the shielding also is around the radio and offer you additional isolation. You can also connect radios from a Cambium network. It's EPMP 1000, and basically you can connect any radio from Cambium which is mechanically identical with EPMP 1000. This adapter comes just in unshielded version because a radio by itself is shielded. And also if you are using a MikroTik router boards, so you can use adapters for a MikroTik router boards. Both come, I mean, these adapters come in a shielded and unshielded version. The only difference, they look same from outside, but the shielding is integrated from the inner side. This is what you can connect, and also might be interesting in performance of the symmetrical sector antenna. So we did one performance test. We compare, we call it old versus a new standard, because we compare twist-port antennas of symmetrical sector and traditional devices. So to be more detailed, we create in this field performance test, we create two links. One link we create with a MikroTik SXT. Here you have a exact model on the both sides. So on the both end of the link was this device. So it's a patch array antenna. We choose an SXT because the radiation angle as well as gain is very similar to the symmetrical sector antenna. So that was the first link, and the second link we created with the symmetrical sector antenna, and we use a twist-port adapter with the mini PCI Express module. And the site where we set up this test was a very noisy site. Around 20 other radios was on the side, and distance between these two APs was 1.3 kilometers, and we did it in Slovakia. And what we achieved, so these are the overall throughput that we were able, or we achieved for both testing links. We tested two different protocols. So one, we tested NV2. This is a proprietary MikroTik protocol based on the TDMA. And we also tested an 802.11. And you can see here really a difference between these two links. This is a few graphs that we made during the testing. One important thing I would like to mention is the graph which is in the left down corner. You can see here two links, two lines. One is red and another is blue, and this is a signal level on each chain of the radio. And here you can see that the chains are very similar, so there isn't any imbalance between a horizontal and a vertical chain. This is very important for a MIMO deployment. This was for the link with the symmetrical sector antenna, and when we use an SXT from MikroTik, in the same graph you can see the gap between those two lines. So there is imbalance between two chains, and this is quite a big one. It's around 5 dB, and it means that you will receive more errors. So then you need to go down with the modulation rate. So you have to use lower modulation rate, and also the throughput will go down. This was for NV2, so the MikroTik proprietary protocol, but same thing happened also for 802.11. When we use a twist-port antenna, so symmetrical sector antenna with twist-port adapter, the mini PCI Express, you can still see that those the level on each chain, the level of the signal is very similar. And in when we use an SXT, the gap is still there, and that's the problem for a MIMO deployment. This was the test that we did, so as a manufacturer, but I would like to also share with you few feedbacks from the customer. So they already tried our symmetrical sector antenna, and they were able, or what they were able to achieve, or how was the performance. This one is an AU wireless, the WISP from USA, and what they did, they replaced an AC sector from Ubiquiti, and they were very pleased with the performance of symmetrical sector antenna, as you can read here. We also have another customer in the USA. It's another WISP, and they were surprised about the vertical performance of the antennas. So even if they mount the antenna on a very high tower, like more than 40 meters, they were surprised that they don't need to use downtill when they would like to cover customers that are close to the tower. We have much more feedback from different WISPs or the ISPs, and they really like the antennas and perform very well. I would like to show you, this is the installation from real life, how the scalability can look like. These guys in Texas, what they did, they have a 90-degree sector with a lot of customers there, and basically they were not able to achieve to connect more customers. So what they did, they just put down the 90-degree sector antenna and mount on such a pole 3 symmetrical sector antennas. So they split the sector into 3 narrower sectors, and they were able to achieve better performance. It allowed them to connect more customers without interferences, and they also what they noted is even if the sector from symmetrical sector antennas overlaps, they don't create any interferences to each other. This is very important when you are trying to split the sectors. All these feedbacks were from the customers, and they already used, but I would like to mention here that we also have a customer in Norway, so in your country, which is using our symmetrical sector antenna. His name is Geir, and he is here on this webinar. So I would like to ask him to share his feedback about his deployment. So from a real guy, you can hear what is his experience with our antenna. Geir, are you here?
Yes, Michael, I'm here.
Oh, perfect. Thanks for coming, and yeah, thanks that you decide to share your feedback. So please, can you tell us what you did, what is your installation, and what is your feedback? What did you achieve, or what are your experience with these antennas?
Yeah, we normally use DSL for our customer, but we had an area where the DSL coverage was very poor. The distance from the DSL is over 5 kilometers, and most of the customers get 2 megabits. So we decided to try some radios, and we want to try a radio from Camium, EPMP 1000. And we started with 3 sectors with normally panel antenna with 60 degrees, and it works okay for everyone on the ground level because they were into the sectors. But we have some customers up in the hill, 15, 20 degrees up in the hill, and for those customers, the link quality was as low as 40%. And as you know, in radio, everyone in the sector should be on the same quality, else everyone will have some problems. So we will, after meeting Martin Barek in Oslo last year, I would try to use this symmetrical antenna. And we ordered a couple of them and put them up in the tower. And the results was that from 40 to 60% link quality to today, we have 80 to 100% link quality of every customer on that sectors. And today, our customers in that area have 20 to 30 megabits, and everyone is happy. I'm happy, the customer is happy. So we are going to use this symmetrical antenna everywhere where we have that kind of customers in a valley, where we have up in the hill. Not everyone is on the ground level. Norway is a country with many, many hills. So in Norway, this is a perfect antenna.
Great. Thanks, Geir, for sharing your feedback. I'm really glad that that you have very positive experience, because these antennas are really working. So thanks again. This is like the end of the webinar, but I would like to mention the last thing here is that we already launched a community portal. So the community portal is, you can find it on rfelab.com, and is something where you can share your feedback. So you can register here for free, and if you have any question or any idea or any feedback that you would like to share with us and also with the other guys, please go there and share it with us. Same if you have feedback with using our product, you can put it there, or you can contact us, and we would like to hear it from you and speak with you. What are your experience? So stay tuned for more information. We are on major social networks. You can find us there. We also have a YouTube channel. Check the YouTube channel. We have more customers that they are sharing their experience with our products. So if you are interested in, check our YouTube channel, as well as a community portal. So this is all from the webinar part. Aslo, are you here?
Yeah, I'm here, and thank you, Mikael, for this interesting presentation. At the moment, we don't have any questions. I just want to inform you that we are recording this, so we will make it public for all your attendees. And thank as well to Geir from Gauldal for sharing his experience with the products. If anybody has any questions, please contact us at salg@avantis.no, or technical issues, support@avantis.no. And all the products are in our web shop, so and if there's anything you wonder about, I'm sure that we also could get, we will contact RF Elements, and they will help us to answer them if we're not able. So then again, thank you all, and have a nice day.
Thank you again also from my side. Thank you that you're coming. As Asl mentioned, if you have technical questions, you can ask also us or any question which comes later from the webinar, so you can ask us. You can put it on the rfelab.com and we will answer it there. So thanks again, and I would like to also thank you, you guys from Avantis, for this webinar.
Thank you, Mikko. Okay, have a nice day. Bye.